Hello and welcome once again to a new episode of Building SaaS on AWS, the AWS SaaS Factory show for builders of SaaS here on Twitch. My name is Anthony McClure and I am a solutions architect with the AWS SaaS Factory and your host for today's show. If you are currently a builder of software as a service solutions, or are just beginning to learn how to build, deploy, operate multi-tenant applications, then this is absolutely the show for you. In every episode, we strive to dive deep into the various different topics of building SaaS. And this episode is no different, as we have a very exciting show for you. But before we dive into that, first, I want to give a big thanks and a big hello to everybody that is joining us today live out on Twitch. If you are here with us today, please jump into the comment section, say hello, give a big shout out to our moderator, Bill Tarr. Let us know who you are, where you come from, and what brings you here today. But without further ado, let's go ahead and get into today's topic, as we have a very special episode with a SaaS customer of AWS called MyCom OSI. So I'd like to go ahead and introduce our guest today. First, I'd like to bring in Mr. Dirk Michael of MyCom OSI. Welcome, Dirk. And also Mr. Chris Williams, Solutions Architect, who works very closely with MyCom. So why don't we go ahead and start with some introduction? Dirk, would you like to introduce yourself? Maybe tell us a little bit about what MyCom does.
Excellent. Yes, thank you very much. Thank you, and hello to everyone, and hello to the audience. Thanks for coming. Yeah, so my name is Dirk Michel. I'm the SVP for SaaS and Digital here at MyCom OSI, and I'll unpack that a little bit for you all. I basically run SaaS and cloud engineering here at MyCom, and I run the CCOE and, of course, platform engineering. One of the topics we'll be diving in today, and what perspective we take on using platform engineering principles and building out a SaaS control plane. As part of that role, I'm also the alliance lead for the AWS partnership, so that's always great fun. I get to work on differentiation programs, and those who are familiar with APN, so that's the AWS Partner Network, so we are part of that network. And we get to work on things like strategic collaborations. We get to work with the SaaS Factory, hence we are here, for example, today. We have touch points with sandboxes where we get to participate in programs where we collaborate. We work on cutting edge technology to bring new experiences to customers. We do things around Bedrock now, so that is great. We really love the data lab kind of program that helps ideate new things with us and really build something out that is working backwards from customers and building something that creates value, right, for our customer base. What else do I do? I'm an AWS ambassador, so that's always great fun as well. So that's another program, or it's a group of AWS experts and technical experts that are sourced from APN companies like ours. And we drive proficiency in AWS. We are big on training and certifications. We really participate in the community as well as within our respective companies to drive adoption of AWS, help people do that, and create differentiating offerings. And other things like productivity, everything that has to do with cloud adoption and digitization. So that's a great community as well. As part of that, as just mentioned, I happen to be an all-star certified member as well. So that means I managed to sit through 13 certifications, right? So that is quite an endurance piece of activity. So
Indeed,
great that we have
yes,
that.
Yeah, my sympathies.
Yeah. But I tell you what, right? So this is really something that I'm big on leadership principles. I love leading by example, and if the manager can do it, then so can everyone else. I'm totally convinced of that. And you get some small things on the side also. So they give you like a golden jacket and things if you manage to get all 13, and that's all fun as well. So you start collecting them like little Pokemons, right? And speaking of that and of jackets, it turns out that the CNCF, the Cloud Native Computing Foundation, is taking a leaf out of your book and has now come out with a blue jacket, right? So now they've sent me a blue jacket. So I'm going to be all set for the winter. But doing all the Kubernetes certifications is also something I really recommend. It sharpens the axe and keeps you close to the things and to the technology that we work with. But all of that really to say that on the show today, we can go deep, we can go wide, we can pick up some audience questions. And I think we should be in a good position to work through all of that and make it exciting. By way of context, perhaps for MyCom OSI, so we are a telco ISV, so our software serves the telco industry, and we really specialize in what we call AI-driven service assurance, right? So let me maybe unpack that, as it doesn't necessarily mean so much for people outside of the industry. So AI-driven service assurance. So in your mind, perhaps picture like a large control center, as you see in the movies, big screens on the walls, with lots of graphs and blinking images and trends and things like that, like an incident command and control center, perhaps. And our software runs in those kinds of control centers. Yeah, it's really, really cool, right? So when you step into one of those things, then, it is intense, right? So we are kind of on those screens, and there's a lot of stuff that we do on the network. So we are really the eyes and the ears of the network, right? And of course, we do many other things as well. But it's so we leverage distributed compute and data processing. We embed AI and ML to generate insights out of the large data set that we consume. If you think about it, companies like us and the networks, the telecom networks, the mobile phone networks, for example, they generate billions of data points per day, right? So we're in the hundreds of billions, multiple hundreds of billions of data points per day. We're running on petabyte, data storage. These are relatively large-scale distributed compute applications, not for the faint-hearted, right? And then there's hot data coming in, there's cold data, there's all kinds of different lukewarm data in between, and we're running on thousands of CPUs. So these are relatively large deployments. And we've been shipping software for 2 decades now. So we've been building these things before cloud was a thing. So that's maybe a good thing to know.
Sure.
By way of context, we started out as building monolith applications like everyone else 20 years ago. Then we started to scale. The network started to be more verbose, generating more data. We started federating things.
So you've seen the entire process, the entire modernization process as well. Yeah.
Yeah, no, we absolutely have, and Chris knows about it, and he's been helping us. But it's exactly that, right? So starting as a monolith, federating the monolith to have multiple instances of the monolith, try to really push that for as long as we can. Then we transitioned to containers around about 2016. We made some big bets early on Kubernetes when, at the time it wasn't clear who was going to win the orchestrator war.
It was a smart bet,
so it was a smart bet. Yeah. So in hindsight, really great. That was a time where you had Mesos, you had Swarm, you had all kinds of different options. You still have some options today, clearly.
Sure.
But yeah, we did make the early bet on Kubernetes, so that was great. And microservices, so we really disassembled, if you like, the monolith into microservices, and everything else is history, right? So then we went into SaaS, and now we're building AI-driven applications. So so we are really kind of at the cutting edge on that side.
Beautiful.
And as mentioned, we are part of the program around ISV program and differentiated partners, and of course, last but not least, we're also on marketplace, right? So that's something that that's always good to know.
Well, that's fantastic. What a great story as well as a company and organization and how that's come about, Dirk. That's fantastic to hear, and I want to hear more, especially about your SaaS journey. But I also wanted to bring in Chris here. Chris, welcome to the show. I think this is your first time being on Building SaaS with AWS, and welcome. Yeah, why don't you tell us a little bit about yourself and how it is that you ended up working with Dirk and MyCom OSI?
Awesome. Yeah, thanks. It's great to be here. Definitely my first time on this show. Did a few shows for a few different topics last year. As introduced, so my name is Chris. I'm a solutions architect, and I work with customers like Dirk, who are in the enterprise software in the SaaS space. We call it the ISV team. And I have the privilege of working with those customers to really help them to be educated about our services, understand how they can get the best use of particular patterns and architectures, and really just enabling them to get the best they can out of the cloud. Dirk mentioned he is a golden jacket holder. I'm also a golden jacket holder, so we have two of us on this call.
Wow, fantastic.
I think Dirk might actually be the first person outside of AWS I know who has them. So it's great to have met him. And that's me.
Fantastic. So, Dirk, maybe getting back into this a little bit here. We've mentioned SaaS. What really kind of pushed you or made you move towards SaaS?
Yeah, that's a really good question. I mean, you got to do these types of decisions very clear-eyed, right? And with as much data as you can. And one of the things that we did, as we always like to say, we really work backwards from the challenges that our customers have, right? So I've alluded to the complexity of the application, or applications like ours, distributed compute, variable load patterns over the day. I mentioned Kubernetes. There are a whole range of things around high-performance compute or bleeding into high-performance compute. I mean, these are difficult things to build out. And for our customers, one of the things that we realized, having been shipping software for the best part of 20 years, is there is really an incredible burden on many of our customers who have a primary objective that is not building out these types of environments to run kinds of applications like ours. So it's really about removing barriers for adoption, accelerating our customers, and what we sometimes call or refer to as time to market, right? So if it takes you 6 months plus, to buy the kit, deploy the kit, cable the kit, commission the kit, get some other software on, get your backup systems up and running, get your security stuff sorted out. At some point after 6 months, you get ready to maybe deploy the application, right? So it's a lot of time. And removing some of these things from our customers was one of the key drivers, right? To really lower the time it takes for onboarding and deriving value from the application that our customers invest in, right? So that's basically one thing, to remove that undifferentiated heavy lifting. And we were hearing this a lot, right? And the other thing, of course, is that applications like ours, they have a whole range of dependencies, right? So as I said, I want high performance compute, I want high performance storage, I want, the fastest network you can get. We have many metrics for all kinds of things that we need because our customers want to have quasi near real time data, for example. And then there is a thing around really solving for elasticity. Right, it's something that's not trivial to do on site. In the same way, it's not so trivial to solve for things like geo-redundancy, right? I mean, telcos themselves are, multi-billion-dollar enterprise capex-driven companies, right? So that's all also to be noted. They know a thing or two about building capacity, right? So they're building the networks that we all rely on every day. Every one of the audience probably has a mobile phone, right? So there's a lot of infrastructure in the world to make these types of networks possible. But applications like ours are a little bit particular. So solving for elasticity, attempting to solve for things that don't require our customers to buy for peak capacity, right? So I have an application like Markham OSIs or a suite of applications. Okay, it can scale to X, and I need to basically buy X plus Y to have a bit of breathing room. So all this investment upfront, build out, and then perhaps grow over time because these types of procurement cycles take a long time. And so on. So we alleviate these types of upfront investments, and then you have all kinds of things around fleet management, compute refresh, storage refresh, broadly speaking, IT refresh. Sure. And then our customers really talk to us about cost performance, and they talk to us about sustainability, right? So and we it's something that we are working on with regards to Graviton and other new generation cost performance sensitive compute options and flexible compute options with yourselves, right? And maybe that's where you can come in, Chris, because we've just started to work on this, right? A little bit around how can we kind of move into that.
Yeah. Yeah, I mean, yeah, I'll talk a little bit to that. I think just to add some additional context here, right? The application itself, this is kind of mission critical. You have different types of workloads that have different types of, I guess, impacts if they go off. This is giving telco networks complete visibility of what's happening within the network, and so by having a SaaS, what it means is that MyCom can offer a product whereby they do not need to have their customers managing these and managing the expectation that they can go down. And as we're about to allude to, it's allowed MyCom the ability to really dive deep and to innovate behind the scenes without their customers needing to be involved necessarily in how they would do these migrations or these transitions. So one example here is Graviton, right? If you're not familiar with Graviton, it's an ARM-based processor that AWS offers, and it's probably the most cost-efficient way to be able to run a compute workload on AWS. Well, if you're going to do that, that's fantastic. You can reap those benefits, but that means under the hood, you're going to have to re-architect the actual application because it runs on a different CPU architecture, transitioning from x86 to ARM64. And so with that, if you was going to roll that out in a traditional on-premise model, that means that you're going to have to build those versions of the software and then work with those customers to be able to perform the upgrade. That probably also means they have to make infrastructure provision, or they need to be able to purchase new infrastructure, which is actually going to support that architecture. And then they're going to have to roll that out. And that's going to be months, if not years, to actually go through this. But by working with us, by working with as a SaaS as well, it means that MyCom is being able to make these transitions behind the scenes. And Graviton's just one of those things, but they can really focus on cost. They can focus on what's important for their customers without their customers needing to necessarily make any changes. They just consume the application as it always was.
Absolutely right. I mean, it's that reminds me of one more thing, right? So, for example, when it comes to disaster recovery, right? So, something that we can bake into the SaaS application itself, and we do the work behind the scenes, exactly as you highlighted, with regards to running recovery days, running game days, really making sure that the disaster recovery mechanism that is there, perhaps not often used, but it is there and proven to be useful and operational at the time that you need it. But it's a really, really, really important thing. And we bake this into a SaaS. Plus, of course, running disaster recovery and backup and restores is not that trivial in the context of cloud native and Kubernetes, right? So you have within Kubernetes itself, we are running all kinds of databases, right? Be it Redis, be it Elastic, be it brokers like Kafka. So you have things that themselves are distributed, and application-aware backups is not something that is necessarily super easy, right? So you just don't take a block backup and then you hope for the best. No, you need to have application-aware backups and other things like that. So you really have the detail and the expertise built into the SaaS offering that 100%. Is perhaps not so easy to replicate on-prem or elsewhere.
100%. I mean, it means that your customers don't need to understand Kubernetes. They don't need to understand how they can go ahead and patch and plan for disaster recovery. They leave it to the experts, which in this case is you, right? You understand you understand the technology, you understand the product that you've built. So it means that they just have to worry about consuming the application and getting the benefits of also everything that comes with SaaS, including things like faster delivery cycles, being able to lower the total cost of ownership, etc.
Yeah, very true. And I guess just before we move on to the next one, I mean, one thing is also about, I mean, we touched on this, but it's the SLAs, right? So you say you have a SaaS offering, right? So you back them with SLAs. You make, you agree that this software is going to be available and do what it's supposed to be doing for, let's say, 4 nines, 99.99% of the time, right? Yeah. That can be really an important thing. And you made this point very saliently, right? That these are often viewed, applications like ours are often viewed as mission criticals, right? Because if you are in a car and you're driving and all your dashboards vanish, all your measurements vanish, you basically lose the ability to drive safely, right? So you don't want these things to go away.
I think your car analogy would be almost like if you turned off the dashboard, you can't see out the window, you can't see what's coming ahead or all around you.
Yeah, exactly. No.
So Dirk, Chris, let me introduce myself to the audience here real quick. So everyone probably recognizes my name from the chat. I'm Bill Tarr. So we've had some technical difficulties. It turns out Anthony was struck by lightning today, We always joke before every show, if he gets struck by lightning, I'm going to hop on. So today, lightning actually has struck. Fortunately, it seems to have just struck his internet, but I'm going to hop on and sort of take over from here. Awesome. So hello to everyone for the audience. It's good to see you all. Morning for me, and afternoon for Dirk and Chris as well. We also have a pretty international audience here, so I'll make a quick call out. If you haven't said hi to us in the chat yet, we've got people from Mexico, US, and Argentina. So we've covered most of the continents already. So if you haven't hopped on already, start chatting with us and ask us some questions, because that'll help us keep the flow of the show going as well. But I really love where the conversation's been going so far, Dirk, in terms of shifting that burden of management off of your customers. But it does shift a lot of that burden back onto you, right? A lot of this management of Kubernetes, a lot of the overall architecture that you've created is to help facilitate that. So I'd really love to dive into the concept that we call the control plane, right? And to me, this is one of the bigger things ever since I started talking to you, Dirk. Control plane seems like the thing that comes up within 5 minutes of us talking about how your control plane's developed, what that looks like. Let's just start clicking into that and seeing where that leads us in terms of what you guys have done to facilitate the management of this large architecture that you've created for all your customers.
Yeah, excellent. Totally. Yeah, so it's difficult to talk to me without eventually ending up somewhere close to the control plane discussion, right? Yes. And I mean, one of the things to say, and I'll transition over to some architecture diagrams, and we can look at some of the resources also that the SaaS Factory puts out that we help others who are looking towards us, who have been there and done that, to kind of take best practices from it. But when we go about architecting a SaaS control plane, we've alluded to this idea, is we really work backwards from the requirements of the customer. So really be very clear as to what requirements you have and what abilities you want to build into the SaaS control plane, so that you, for yourself and your context and what you're building, has the best possible service product market fit in that sense, right? You really want to make a difference for your customers and make it valuable for them. So where do your customers come from? So now we understand this a little bit, right? So we talked about telcos, we talked about, lots of data being generated and consumed and processed and graphed up in operation centers and used for analytics and so on. But our customers come to us with big fibers, AWS Direct Connect on leased lines, right? So a 10 gigabit kind of leased lines coming in. So there's a lot of data really coming through. So really, it's a B2B kind of a SaaS context. So that's the first thing to understand. How do your customers actually come to you, right? So it's not a B2C kind of thing where it's a web app sitting on the internet somewhere. It is not that, right? So it's on the other side of the spectrum. So you're coming in with heavyweight leased lines, lots of data push coming in. So that's a key requirement. Another requirement is optionality around different tiers, right? So we've got our customers who have different environments themselves. They've got test environments, dev environments, staging environments, pre-prod environments, production environments, right? So people have 3, 4, 5, 6 different environments, and you kind of cater for those, right? So they have different SLAs, perhaps. They've got different compute options built in there. You've got different resiliency options in there, one zone, multi-zone. So you have, so you kind of work alongside these types of dimensions to build out the capability of the control plane to provision the kind of tenant that you need, and you build out those tiers, right? So that was important for us and our customers. Another thing, evidently, is around security, right? So, I mean, the list is very long, but security and compliance and governance is something that is really important for regulated industries. 27001, for example, building in the controls. You have your preventive controls. You've got your detective controls. Sometimes you kind of bleed a little bit into proactive controls. So, so you have to build up the mechanisms to show to auditors that you are indeed 27001 compliant, right? And you get audited on a yearly basis, things like that. So we need to build all of those things into the SaaS control plane so the tenants get imbued with these types of characteristics.
Quick question.
Private networking. Yes.
So, sorry, but before we move off of compliance, ISO 27001. So you guys have compliance. You have auditors that confirm that compliance. You're in a highly regulated industry, though. Do you ever have customers who really are very demanding in terms of being able to see the actual compliance reports, to be able to dig into specific controls, or even asking you for custom controls that meet their own compliance requirements?
Yeah, good question. I mean, so at various levels, these types of things happen. So we contract against certain governance and compliance criteria. Then throughout the life cycle of a customer journey with us, we typically do provide visibility around how we do in these assessments and in these audits. We are a little bit selective, of course, as everybody would be, as to what can be shared, what can't be shared. There are confidentialities that we need to observe and things like that. But broadly speaking, there is always a relatively active communication with our customers on the topic of maintaining compliance, right? So one thing is to be compliant at a given point in time. It's something entirely different to be able to prove that you're compliant over time. All right, so that's something that is also built into our systems, and that's where we leverage things that sit, within AWS as well, right? So there are many mechanisms out there to help, let's say, the auditor persona to really generate these types of reports. We can touch on those a little bit later. Also, as part of the demo, I have something I can show. There's a security hub. There's some other supporting services in the background, like AWS config, a guard duty, and different other things that collate and analyze logging data. And yeah, so we have the possibility of also implementing custom controls. Some customers have requirements for custom controls that are important to them, not always related to 27001, but a customer requirement for us is always an opportunity to shine, and we like to implement those.
Right on. Yeah, I think we might want to do a whole nother show just talking about how you guys meet all the compliance requirements in a highly regulated industry. But that's not what we're here to talk about today. I'd really like to let's get back to the control plane. And I'll stop distracting us with all these other interesting topics.
No problem. I mean, I totally love that, right? So security really is something that we're passionate about. It's job zero, as we call it, right? So and then you have the opportunity to kind of talk about organization, control tower, and other governance services. But perhaps just to nip back, another area that is really important for us in understanding how to build out the control plane was the resource isolation model, right? So you have various options. I'll come back to it again, when we talk perhaps about the 50 shades of SaaS, right? So there are various, different shades for you to choose from to find your Goldilocks zone. Where do you really shine, and what trade-offs do you make? But our customers have a very strong, and historically have had a very strong isolation set of requirements, right? So these are things that we would then also build into the SaaS control plane, right? And the SaaS control plane then ultimately takes these requirements and converts them into something that itself can use to provision the tenants when they come in, when they are needed, the spin up tenants, change tenants, lifecycle manage the tenants, delete and offboard a tenant. So there are all of these types of lifecycle stages, as we call them, where the control plane plays a role of making this possible.
Yeah, we have a very interesting. I'm going to bring this up on screen. It's a little long, so it might cover up all of us, but let me bring this up anyway and give you a second to read it. But at a very high level, we're getting some really interesting questions about platforms and how to make distributed systems that are highly reliable. It brings up a number of different topics here, but I think and there's actually a second part of this, so I'm going to hide this and I'm going to show the second part really quick if everybody has seen this. But these are really good questions around platform engineering, DPR in here, integration and interoperability. So very quickly, I don't know if you'll be able to really address all of this right now, Dirk, but speaking to as a platform engineer, because this is something that I think is a fairly new topic to a lot of people in SaaS and in the cloud in general, the idea that there's platform engineering that manages all of these things. Can you just quickly sort of speak to this platform engineering role and perhaps some of the points that are brought up here in this question?
Yeah, totally. I mean, platform engineering really is a discipline of building developer-centric, if you like, abstractions with a view of building self-service capabilities for those who work in that space. And it kind of builds on top of giants, as we like to say. So it builds on top of DevOps principles and attempts to create a developer-centric experience that is, however, abstracted, right? Quote unquote simplified. not everybody needs to understand Kubernetes in all of its shades and complexities, as you've said earlier, but we do, and we build these into the system and then provide higher level constructs that people can consume. And that's really important for developers. And there's a reason why we ended up choosing this idea of internal developer platforms and platform engineering as a principle around which to build the SaaS control plane, because we were doing all the aforementioned things already, right? So we were really in a place where we knew that the various actors within the business are sensitive already and are, if you like, knowledgeable around these things. So it was very natural for us to build on that. I saw a few things pretty briefly on that note. GDPR, how do you do that, right? Okay, so it's not simple, right? We don't happen to be dealing with PII, personally identifiable data,
Right.
but we have things like data residency, right? So in that particular case, you just attempt to really make sure that you provision the tenants in such a way that they run in the region where your customer is, right? And AWS is building out more and more regions over time. I lose count. Every time I look, the number is bigger, right? So you'll probably have to tell us. But regions become, so regions are clusters of data centers, geo-redundant constructs running in a country. So that's one way to address that. There are other ways to address that with AWS outposts. I mean, there are various ways of kind of addressing that. And then, of course, with regards to data encryption, addressed in transit, end-to-end encryption. So data protection, broadly speaking, is important. As I mentioned, we're not in the PII space, so that's okay for us. But we nonetheless have to adhere to these types of data protection requirements. And yeah, maybe one more thing that we will come back later to, which is everything that you do typically, given that DevOps is kind of wired into this idea of platform engineering and developer workflows. We do everything in Git, right? And we'll see this later in the demo, right? So everything we do is to do in Git. And what happens when you do things in source control? One of the things, at least, that happens is that you have auditability, traceability. You've got, the Git history, the commit history. You're able to see who did what when. And that's a powerful base of drawing from when it comes to proving compliance.
Right. Yeah, let's get back on track, Dirk. These are some amazing questions, and we've got some more that I'm going to bring up in a little bit. But I would like to get into the demo a little bit and start talking about some of the context of what you guys have built, because I think that's what a lot of the audience is here to see.
Absolutely. So to kind of stage that up, so let me see if I can get this here. So I've got, in fact, I was just on Bedrock earlier to kind of build an image on the command and control center, and just Titan came up with an amazing picture. I'll send it to you and post it. I think it's very cool. But let me see if I can get the first diagram up and running.
In the meantime, we popped your question into there as a quiz of how many AWS regions there are without looking. And we get trained on this, by the way. We get, Chris and I get regular training on how many regions and how many AZs we have. And I'm still never right, because it's changing so rapidly. You really got to keep on top of it constantly and be up to date. But it's an interesting challenge, even within AWS, keeping up with all these changes. And I think the answer right now, if I'm not mistaken, is 33.
Yeah,
so
it is.
People check me if I'm right on that.
Excellent. So I think I would be ready to share. And I had another audience quiz. I mean, that was the idea, right? To kind of put up this Bedrock image and then say, okay, please try to guess the prompt I used in order to generate the command and control center image, right?
Quiz.
So
yeah,
we'll have to do that later. Right. You've got me back on stage with the screen share?
You are on stage.
Yes, everyone should see your screen now, yeah.
Okay, excellent. Yeah, so let me give you a little bit of an orientation as to what's going on here. So this is the SaaS control plane architecture. We're kind of, it's sequenced and numbered, so you can probably take a screenshot and see it on your in your own time. But on the top left, we are really starting with the personas that are interacting with the control plane, right? So I mentioned earlier that we are really in the B2B space. So tenants and the lifecycle management of all of this is really done by tenant admins, right? So this is not a B2C self-service onboarding experience. We do the onboarding for our customers. And that's quite natural, right? Because people have to come up with direct connects. That takes 4 weeks plus to kind of set up. So we've got the tenant admins that work with our customers to do all the networking and the, let's say, connectivity side of the house. But the control plane then is also driven completely through Git, and itself is running on GitLab CI, as you can see here, and GitLab CI itself is running on Kubernetes, right? So we are doing all this stuff again backed by Kubernetes, and we are standardizing on that. Our control plane has a whole range of core components. So one of the inputs on the top left is effectively a YAML file, right? So we love intent-based configuration. Everybody who's been in that space begins to ask themselves how much YAML is too much, but we'll get to that. We have opted into a control plane backed by platform engineering in a way that also leverages CDK, right? So CDK is an important aspect for us to build out and provision and also lifecycle manage AWS resources and services that we use as part of the tenant creation, right? So it's a combination between AWS CDK, the Cloud Development Kit, and of course, AWS SDKs also form part of that. So the customer, or if you like, the user submits an intent-based description in the form of a YAML file to say, I want a cluster that has XYZ characteristics, and the control plane takes it in as a commit, and then executes a pipeline to generate the tenants at the bottom, right? So here,
let me interrupt you there, Dirk.
Yep.
Because I want to make sure everyone understands exactly what you're describing here, because you're talking about these YAML files, but really these YAML files describe the environments for each one of your tenants, right? So it's like a YAML file per tenant, right?
Exactly right.
Yeah, and so what you're doing, like there's different tools out there that allow you to manage infrastructure, but you've chosen a very specific path that allows you to branch off and have different versions of what you're deploying for your customers while keeping a single code base behind all of those. Is that right?
Yeah, exactly right. So this is where you can opt for certain configurations per tenant, and they all get provisioned through a common actuator, right? So a common provisioner that is able to extract the intent-based declaration as to what the tenant should be looking like, extracts all of those variables, and I'll show you the YAML file in the demo. Extracts those variables, injects them into the CDK's configuration, and then executes the CDK deploy on the back of those parameters that have been extracted, straight from the submitted YAML, right? So that's kind of how that works, and then you end up with multiple tenants with different characteristics, isolated in a particular way, by account. So each tenant has its own account. We talked about strong isolation, has its own cluster, its own set of VPCs. I mean, it's all private, right? So it's strongly isolated in that way, but they will have the characteristics requested. So it's a common control plane, and you have a common code base. And what's also true is that all of those tenants, or the control plane, generates Git repos for all of those tenants, right? So that's kind of what we say here in the center of the diagram, right? That these Git repositories per tenant, that's part of the magic, right? Where once the tenant request has come in and the tenant has been provisioned, the control plane gives you back a set of Git repos that you can use to change the configuration of the tenant over time. Maybe there is an application upgrade coming. Maybe something else changes. Maybe there's a configuration change you would wish to apply. And all of those get managed through Git. And we have this principle of GitOps, and we use FluxCD as a GitOps operator in our stack here, indicated here in these blue arrows in the center of the diagram, that reconciles and looks to the Git repo to receive any updates with regards to new intents coming through, and changes the cluster in such a way to comply with the intent, right? So the whole thing is really structured in this way and deeply embeds the principles of GitOps and platform engineering.
Yeah, I was just going to add to this. So when we discussed earlier benefits of SaaS, and now we're talking about GitOps here, The fact that everything's managed in files and automated in these ways means that actually you've really got a bit of a disaster recovery strategy in the sense of not the data, but actually the architecture. And if you're thinking of maybe what that would look like on-prem, I know, Dirk, we've actually gone through this discussion before on the workflow that it would take. If you're creating all these infrastructure components that someone's going to have to manually go provision, install the software on, this solution is actually doing everything for MyCom's solution, right? And it's following a standard schema, a standard definition, which means that actually you can roll this out, to 1 customer, 10 customers, 100 customers. The actual solution, the way in which you do it is still the same. And so it's just much more scalable, faster for the customers, and it's repeatable.
Yeah, exactly right. And the other thing, of course, is here illustrated with item 4, is that the control plane, on the one hand, it needs to have the capability of really building out and provisioning the tenant configuration that is required. But also, you need to have a possibility of really observing and understanding how the tenants are doing, right? Health status, change of status, which events are happening, security status. And given that we do things in the cloud native way, we are leveraging things like Amazon Managed Grafana and Amazon Managed Service for Prometheus and things like that. Right, so we are scraping the metrics from each tenant, and the control plane, of course, in that sense, is multi-tenant. That's perhaps also one of the things that are not always well understood. Right, we talked about strong isolation, and we've got a silo model on resources, and then the next thing you might believe is, oh, but that's not multi-tenant. But no, it's it's upside down, right? So the control plane is where the multi-tenancy, in a sense, lives, and then you decide on the resource pooling, right? So we have, for example, common services like common security services that cut across all tenants, and then we have other services, including some security services, which are specific to each tenant, right? So the whole thing is set up as a multi-tenant SaaS control plane, but the observability and being sure that you are able to capture the signals relevant to understanding tenant health and tenant load, other tenant metrics, perhaps tenant billing data. There's all kinds of other things that go into building a control plane. That's where Grafana and Prometheus, in our case, come in as well, and you build that straight into the control plane.
Right. And I think that answers the question that was just asked too. If one tenant has its own EKS cluster and different VPCs, is a control plane really shared amongst the clusters? And in a sense, I guess, yes. How would you answer that, Dirk?
Yeah, exactly. So in a sense, yes. So there are some common services, as we mentioned, as part of AWS organizations, right? So AWS organizations is a mechanism that on the one hand lets you do things like account vending, and there's this concept of account factory and so on that can bootstrap accounts and run specific service catalog implementations on things that you want, on each of those accounts. The resource isolation, where you have got a one-to-one mapping between environment, let's say test environment for the customer, you've got some other environments for the customer, you would still always isolate them. In fact, we do that, right? Strong isolation at cellular level, at account level, where we just maintain that separation. But there are multi-tenant considerations that happen within the control plane. And as we just said, the lifecycle management happens through the control plane. So it's multi-tenant in that way.
Dirk, I know we wanted to show a little bit of the application plane, but we're going a little bit longer on time than we thought. Maybe would it be okay if you brought up the code so we can actually see the YAML file that we're talking about? And we'll come back to this if we have time at the end, but we only have around 10 minutes left before we need to close.
Oh, wow. How time flies when you're...
Especially when we're talking control plane. I feel like this happens to us every time, Dirk.
Yes, it does.
This is Dirk's pride, the control plane. Like,
yes.
Most conversations around SaaS, he'd be talking with great pride.
Yeah, excellent. And I mean, we're just honestly scratching the surface, right? But you're probably still able to see my screen. Am I still on stage?
Indeed. Yep.
Yeah.
Excellent. Okay, so I've zoomed in massively. So I've got a wide screen. So this is super large on my side, but I hope it's visible on your end. It's okay. Yeah. Okay, so one of the things that we can zoom into here is indeed that YAML file that we said, right? So that is something that is part and parcel of the interaction with the control plane. In our particular case, you can basically start off with saying, what kind of applications would you like to run? Right, so we've got different kinds of applications. We've got things like ProInsight, that's AI-powered forecasting, proactive and predictive maintenance type of application. That is implemented on the basis of AI and ML. We've got NetExpert, which is a fault manager. So we've got some brand names on the application side. So, a tenant, based on a customer subscription, would then have a selection of EA applications, right? And we will come back to that, what it means. All of those applications are effectively shipped as Helm charts and deployed as Helm charts, and fit very nicely into this GitOps way of working and multi-tenant SaaS control plane. Something that is interesting to note is ACS, if you like, versions, right? So we have this idea of control plane versions and tenant versions. That would be one of the big things I would give everybody on their way who is considering building something like that. Be sure that you have very tight version controls around your own SaaS control plane and tenant versions. Remember, when it comes to SaaS control planes and SaaS generally, I would say you are building an application to manage another application, right? But you are building an application, right? So you have the source code, you've got the base, you have all of the other development principles you would follow. And semantic versioning just goes part of it. So you have a CI/CD backed build and publication software factory that also allows you to generate the control plane, right? So here is where we would manage that. Then, of course, we come back to the point we made earlier around tenant tier definition, right? So it's very innocuous, right? You say tenant type, I want one zone. And as if by magic, it goes away. CDK extracts these types of parameters and is able to provision the tenant in such a way that it is genuinely a one-zone deployment, right? So we make those choices automatically in our code to say, okay, now it's a one-zone database. It's not a multi-zone database. Perhaps there is some storage, and then the storage is one zone, and it's not multi-zone. Where do your compute nodes run? Okay, so they run in a dedicated availability zone. They don't run across multiple. Things like that, right? And if you flip that around to a 3-zone, it would just generate, a multi-zone tenant capability. Same for compute options, right? We can run an entire deployment on Spot, right? By way of example. And this is going to be for like dev environments, things that don't have stringent SLAs. They can run on Spot. We have some stateful components that are sensitive to Spot. So there's also this idea of fleet tiering. So there's a whole range of complexity that we can build in. Then it comes to some tenant-specific parameters, right? So you can give customer names, regions where you want to be in. And that goes back to this GDPR question we had earlier. How do you really determine where you want this tenant to run and where you want things to be? So you can parameterize that. You have the possibility of specifying very specific retention periods. Customers may have very long retention periods. Others have shorter retention periods. So there's a possibility of kind of adjusting things like that. There are other features that you might want. Maybe you want a private CA in terms of a certificate authority. Maybe there are some transport family related features that you need. We call those things the pickup zone. So you really have the possibility of defining the characteristics of the tenants that you need, right? Some other things that are not always needed, maybe in a temporary environment like the one that I've built for you here. You can, enable logging, disable logging, integration to the observatory that we mentioned earlier. Observatory is the name that we came up with to reference this monitoring and observability overlay that we talked about, right, with Grafana and Prometheus. And the list just goes on. You want an Oracle database, that's fine. You want a Kafka cluster, that's fine. So that's how you build these abstractions, right? So these are consumable building blocks that are just defined here. And we provision them, right, as and when needed. And EKS almost the same, right? So here we've got this concept of consolidation features. EKS is always a great demonstrable feature. Also with Carpenter, you can see here that we use Carpenter as our intelligent cluster autoscaler. And that's really something that everyone can connect to quite intuitively, as we are able to change, or the application load is able to influence and change the compute fleet that happens to be running. So we have just-in-time compute. And Carpenter, as our cluster autoscaler, is able to spin up and also tear down and also optimize the compute fleet in response to what the application is doing, right? So there's a whole bunch of goodness built in there with horizontal pod autoscalers, other Kubernetes mechanisms that really make the application respond to load and make it breathable. And we do that very tightly coupled with having a just-in-time compute fleet, right? And yeah, so I have some other things I really wanted to show. I have a little bit of a in this particular case EKS demo with Carpenter spinning up nodes, taking the nodes away as the load changes, but not sure how we're doing on time.
We've got about 4 minutes.
4 minutes. Yeah, before we need to
4 minutes. Okay.
Yeah, a little tight.
Maybe I want to show something just so that we've touched on it, right? On the
could you zoom in a little bit?
Oh yes.
Yeah. Well, yeah.
No, that's maybe good. So what I've done, if you have noticed, I've highlighted that a little bit with the retention period being like set to 1 day and different things like that. So given that this is just a temporary build out, I've made it so that we would trip certain security standards and findings in Security Hub. And Security Hub really is the window into the state of the security. And yeah, so it's a sensitive and sensible entry point for our SecOps team. So here you see, okay, 86%. I've made sure that we have some failures here. Otherwise, it's less compelling to look at. And as I was scrolling down just before the show, I thought there's one interesting thing here. It really picks things out. It says, okay, RDS instance should have automatic backup enabled, and yes, of course it should. And all of those are just mapped through to remediation actions, right? And that's really where the genius of this lies. And it has these conformance packs to give you the compliance standard. But here, to make sure that this alert triggered, you can see the allowed values are between 7 days and 35 days. Of course, we in the YAML set it to 1 day, and voila, it triggers the finding, right? So it really is a very, very effective mechanism to understand your configuration security posture. It has many other capabilities. We haven't scratched the surface very much. We did mention guard duty. But there are many other supporting services in the back of Security Hub that contribute findings, right, and make you appreciate the overall security posture at runtime.
We got a question that's very relevant to what you're showing right now. So how are the AWS security compliance standardized, keeping in mind the wide range of standards available in the market, which I think connects directly to Security Hub, which you're showing right now. But how does that connect back to ISO 27001 or SOC 2 or any of the other standards?
Yeah, that's a good point. So here, I mean, to begin with, there are a range of pre-packaged security standards in Security Hub, and you have, if you like, complementary rule packs at AWS config as well. So you have these two kind of big areas where you influence what you're looking at and which security standards you want to be activating. And AWS do a great job in having these findings and rules curated for you. So often your job becomes to exclude certain rules that you might not actually need in your particular context. But here we see foundational security best practices, which is the one that I left active. We absolutely run the CIS foundation benchmarks for those in the payment card industry. there's PCI DSS that Security Hub also supports. So you have NIST is there as well, and yeah, so you have the possibility of really enabling these packs backed by config rules and other rules, and it then starts reporting findings and aggregating findings, not only by account. I mean, here I'm showing just one particular tenant, but of course, as part of the control plane, I see all the tenants, right? So there's this concept of Security Hub aggregators, and you see your full estate, everything being integrated, multi-tenant as well.
Perfect.
Excellent.
Okay. With that, I think we're just about at time when we want to wrap up. Dirk, Chris, thank you both very much for joining. This has been a great topic. I think we could spend another 2 hours talking about the control plane alone, Dirk, and we still haven't really gotten to the application plane. It's been amazing talking to you. For anyone who's interested, Dirk, one more time, the company you work for, and how anyone can reach you or meet you at any conferences you're going to be speaking at.
Yeah, absolutely. Please come and find me on LinkedIn. I'm going to be around at the usual conferences that you expect me to. So we just had a AWS Summit here in London. That was absolutely amazing. Met many customers and partners. KubeCon is a mainstay. AWS reInvent is around the corner in November, right? So it may seem far away, but it's already around the corner. And yes, please reach out. Also happy to be contacted with my hat of AWS ambassador. But yes, and anyone who's jumping on the SaaS journey, please get in touch and find us on LinkedIn. And of course, I think we can drop Micom OSI as a URL into the chat as well. People can find us there and learn more.
Perfect. All right. Well, thank you, everybody. Thanks for joining Building SaaS on AWS, and we'll be back on in a couple weeks. Take care, everybody.
Thanks.